PowerPoint speech. Title, Capital Investment, or How We Plan to Conquer Madripoor 1 Square Foot at a Time. Presenter, Baron von Schnitzelheimer, CEO of WurstTech Industries LLC. Slide 1, Welcome to the Future of Engineering, STM32 meets the Comet Cyclone. Subtitle, When Spaceborne Mecha Meets Microcontrollers, and We Still Need Coffee. Laughs dramatically. Ladies and gentlemen, esteemed venture capitalists of Madripoor, esteemed investors, and those of you who are just here for the snack, so welcome. I'm Baron von Schnitzelheimer, CEO of WurstTech Industries LLC, the name you've undoubtedly heard whispered in the dark alleys of Madripoor. But don't be alarmed, I assure you today I am not here to conquer the world, yet. Instead, I bring you an opportunity to join me on a venture so lucrative, it might just require its own soundtrack. Today, we're talking about Robotech Park Drive and Comet Cyclone Road, Madripoor, a prime piece of real estate so electrifying, it might just make you reconsider your current investments. And don't worry, my engineers are working day and night to ensure that nothing goes wrong, at least, nothing too catastrophic. Slide 2, Property Overview, the empire you've been waiting for. Property address, Robotech Park Drive and Comet Cyclone Road, Madripoor. Square feet, 208,000 SF. Net operating income, NOI, $4,200,000. Capitalization rate, 10%. Debt service coverage ratio, DSCR, 2.05 now. You may be asking, Baron, why should I care about this square footage? Well, let me tell you, it's not just any square footage. It's 208,000 square feet of industrial innovation, so rich with potential that even my accounting team's spreadsheets have started to glitch. The net operating income is a juicy $4.2 million, which is more than enough to make your accountant slightly uncomfortable, in a good way, of course. The capitalization rate is a stellar 10%, ensuring that your returns will come at you faster than my rival, Count von Budget Cut, can cut corners. And with a debt service coverage ratio, DSCR, of 2.05, we are not just meeting our obligations, we're dominating them like a finely aged bratwurst on a summer grill. Slide 3, Occupancy and tenant quality A, filling up faster than a speeding cyclone. Occupancy rate, 85%. Tenant credit quality, B. Lease expiration schedule, 2025 to 2030. The occupancy rate stands at 85%, which is more filled than my workshop after I've promised free pretzels to all the engineers. The tenants here are responsible, and while their credit quality may be a humble B, don't worry, they've got good taste and solid reasons for it. The lease expiration schedule stretches from 2025 to 2030, giving you years of steady cash flow. Think of it as a long-lasting relationship with a tenant who knows how to cook up a great deal, one that lasts longer than most of my enemies' attempts at world domination. And speaking of domination, we currently have 1,387 engineers working here, all of whom are as passionate about their work as they are about their lunch breaks. Don't ask about the last break, it's a long story. This building is not just filled with tenants, it's filled with potential. Slide 4, the money talk, because you've got to love the numbers. Effective gross income, $6,500,000. Operating expense ratio, 65%. Market rent versus in-place rent, market rent, $10.80 per SF, in-place rent, $10.54 per SF. Alright, let's cut to the chase, see the money. With an effective gross income, of $6.5 million, we're rolling in cash faster than a shipment of premium sausages. The operating expense ratio, stands at 65%, meaning that we're keeping costs lower than the current exchange rate between a bratwurst and a baguette. Now, you might notice that our in-place rent is slightly below market rent. Sure, we could be charging more, but why would we? We're building something spectacular, something that will have tenants begging to pay more just to be part of the WurstTech legacy. We're ahead of the game, but don't worry, when the floodgates open, we'll be ready to cash in on that market rent. Slide 5, the numbers behind the magic A when calculators start blushing. Loan-to-value ratio, LTV, 75%. IRR, 10%. NPV, $5,500,000. Cash-on-cash return, 8%. Let's get into the real details, shall we? You might be wondering, Baron, how much do I need to put into this operation to see returns worthy of a true villain? Well, let's break it down. Loan-to-value ratio, LTV, is a manageable 75%. No crazy gambles here, just the perfect balance between risk and reward. The IRR is a solid 10%, ensuring your profits come in faster than I can sign a deal. NPV at $5.50 million, and now that's what I call an investment worth its weight in golden pretzels. Cash-on-cash return is at a whopping 8%, so your return will keep you smiling like the chef who perfected the schnitzel recipe. Slide 6, Valuation and power broker score are the big picture. Valuation, asking price, $32 million. PPS, selling price per square foot, $153.85. Power broker's score, 4 stars. Here's a big SK $32 million. And for $153.85 per square foot, you are not just purchasing property, you are purchasing the future of Madripoor. And as for our power broker score, it's 4 stars. That's practically a Michelin star for real estate, which makes us the top tier choice in this investment game. Slide 7, why choose us? The WurstTech advantage. Now, you might be asking, why should I choose WurstTech Industries LLC over all the other companies out there? Let me tell you, it's simple: innovation. With Baron von Schnitzelheimer at the helm, we offer innovation that will knock your socks off. Don't worry, we've got engineers for that. Sustainability. Because saving the world while making a profit is what we do best, although the energy for our secret lair may require some clarification. And of course, a sense of humor that will keep you entertained while your investment keeps growing. So, what do you say? Let's invest in greatness. Let's make Madripoor the next Silicon Valley, just with more schnitzel and fewer traffic jams. Slide 8, thank you. Let's get this show on the road. Thank you, my esteemed guests, for your time today. I look forward to our partnership, our shared profits, and most importantly our inevitable victory in this capital investment game. Let's launch this project into the future and maybe, just maybe, we'll take Madripoor with us. Laughs maniacally. End of speech. Page 1. Slide 1, welcome to the future of engineering. STM-32 meets the Comet Cyclone. Subtitle, when spaceborne mecha meets microcontrollers, and we still need coffee. Slide 2, what's the Comet Cyclone? Origin, from Robotech's Expeditionary Force Marines. Because saving the galaxy is a full-time gig. Design, spaceborne mecha unit with 4-arm-mounted auxiliary boosters. Think Iron Man's little brother. With missile pods. Roles, recon, courier, sniper support. It's like Uber Eats for lasers. Armaments, 660mm missile tubes, because why not? 2 GR-103 missile pods, GR-103, guaranteed results, 103% of the time. EU-5 pulse beam rifle, pew-pew with style. Crew, single pilot, social distancing compliant. Slide 3, why STM-32 in the Comet Cyclone? Processing power, STM-32 microcontrollers have the brains to handle mecha controls, and maybe play Tetris on the side. Peripheral integration, USB, sensors, and pulse beam rifle targeting, because point and shoot isn't just for phones. Compact design, fits neatly into a mecha, Raspberry Pi. Slide 4, breaking down the PCB design, aka, the real magic happens here. Schematic setup, STM-32 microcontroller and its best buddies, decoupling caps and crystal oscillator, like a rock band for electronics. Power supply and connectors, because mecha don't run on AAA batteries, yet. USB and SWD debugging, so you can fix bugs before your Cyclone self-destructs. Layout, PCB setup with mounting holes, no wobbly PCBs on my watch. Placement of critical components, MCU, crystals, USB, and that one LED that says I'm alive. 3D models added for spatial vibes. Routing, decoupling caps routed like it's a Formula 1 track. Crystal routing with precision, the MCU won't tick without its bling. Power routing so solid it could pass for Thor's hammer. Slide 5, Comet Cyclone plus STM-32 equals Space Age Synergy. Cyclones boosters, STM-32 controls precision maneuvers, fancy way to say zoom zoom. Missile launches, targeting enhanced with STM-32 PWM control, because hitting the target is always better than not. Pilot HUD, real-time telemetry powered by the STM-32, also shows coffee levels for the pilot. Slide 6, manufacturing files for intergalactic success bill of materials, BOM. Don't forget those decoupling caps, resistors, and intergalactic approval stickers. Gerber files, for PCB fab. We're not in the hand wiring business anymore. Pick and place, CPL, SMT parts aligned like troops before a battle. Slide 7, challenges and humor challenge, syncing Cyclone thrusters with STM-32 firmware. Pro tip, avoid using delay loops. Why did the Comet Cyclone break up with the Raspberry Pi? It needed something more real-time. Slide 8, the Grand Vision mission, build a next-gen Comet Cyclone, powered by STM-32. Outcome, a seamless intermeshing of hardware and mecha, and maybe a Netflix spin-off. Call to action, let's make this Cyclone blow the competition away. Slide 9, thank you for riding the Cyclone. Subtitle, questions? Comments? Misfired missiles? Our debug team is standing by. Page 2. Slide 1, the ultimate fusion, STM-32 and the Comet Cyclone. Subtitle, where high-tech meets high-octane space mecha. Slide 2, The Comet Cyclone. A quick breakdown. Origin, straight outta Robotech, Expeditionary Force Marines. Purpose, recon, courier, and sniper support. Think of it as a galactic multitool. Key features, spaceborne mecha unit with 4-arm boosters, because regular arms are boring. Armaments, 6 missile tubes, 2 GR-103 missile pods, and the EU-5 pulse beam rifle, for those who take pew-pew seriously. Crew, just one pilot. All the glory, none of the backseat drivers. Slide 3, Mission, STM-32 PCB for the Cyclone. Why STM-32? Brains, advanced processing power for multitasking. Brawn, handles power control, thrusters, and targeting systems. Beauty, compact and efficient, fits perfectly into our interstellar masterpiece. Slide 4, Step 1, Schematic Design. Key highlights, STM-32 MCU and decoupling caps, because stability is non-negotiable. Crystal circuitry, keep your Cyclone in sync. Without it, it's just winging it. USB integration, for debugging and software upgrades, or charging the pilot's phone. Power supply and connectors, reliable power, no excuses. Humor break, why did the Cyclone refuse to fly without USB? It couldn't handle the lack of connection. Slide 5, Step 2, PCB layout. Placing components like a Pro, MCU front and center, decoupling caps nearby, think of them as its entourage. Switches and connectors positioned for pilot accessibility, not under the missile tubes, please. 3D models added for the cool factor. Design touches, routing paths clean enough to make your grandma proud. Mounting holes for stability and 0G, no shaky Cyclones here. Slide 6, Step 3, routing precision is key, decoupling and crystal signals routed with care, because we love functional boards. Power lines thick enough to handle the Cyclone's thirst for energy. Finalizing with a design rule check, DRC, if it ain't green, it ain't clean. Slide 7, Step 4, manufacturing files. Files you need, them, bill of materials, all your components in one tidy list. CPL, component placement list, for when you want machines to do the hard work. Gerber and drill files, the blueprint to your Cyclone PCB masterpiece. Slide 8, what could possibly go wrong? Challenge, routing USB signals without interference. Fix, shielding and solid grounding, your Cyclone deserves less noise than your neighbor's Wi-Fi. Why did the PCB flunk its CRC? Too many short answers. Slide 9, the vision of perfection. Cyclone meets STM-32, thrusters blazing, missiles firing, all powered by our rock-solid PCB design. Outcome, a smoother, faster, and smarter mecha. Future, pilot-ready Cyclones cruising through galaxies, or PowerPoint presentations. Slide 10, Candor, all systems go. Subtitle, ask me anything except my secret decoupling capacitor layout tricks. Closing. Remember, a good PCB design is like a Cyclone missile, it hits the target every time. Page 3. Slide 1, Intimation Greatness, STM-32 meets the Comet Cyclone. Subtitle, because mecha without brains is just a hunk of space junk. Slide 2, Introduction. Welcome to the future. Thanks to 2 years of support and a million views on our STM-32 tutorial. This session, combining KiCad 6 PCB design with the iconic Comet Cyclone. Free Udemy KiCad course? You bet. Certificates available for all you overachievers. Why intermesh a Cyclone with STM-32? Because low-tech isn't in the Cyclone's vocabulary. Slide 3, what you'll learn today: how to use KiCad 6 like a pro, no degree in wizardry required. Design STM-32 based hardware, from schematics to an actual PCB. Transition from Arduino tinkering to professional level engineering, time to graduate, folks. Manufacture your hardware using JLC PCB. Warning, side effects may include PCB envy from your peers. Slide 4, Comet Cyclone Overview. Quick specs, origin, from Robotech, Expeditionary Force Marines. Affiliation, Robotech Marines. Roles, recon, courier, sniper support, no pizza deliveries, sadly. Armaments, 6 missile tubes, 2 GR-103 pods, and the EU-5 pulse beam rifle, for those long-distance disagreements. Crew, a single piloter because two's a crowd in mecha terms. It's like a Swiss Army knife, but cooler and deadlier. Slide 5, the mission: integrate STM-32 PCB design seamlessly with the Cyclone. Enable features like advanced targeting, recon, and reliable communications. Add USB support because even Cyclones need firmware updates. Imagine a Cyclone running on outdated software. Tragic, isn't it? Slide 6, Step 1, Schematic Design. Key tasks, place STM-32 microcontroller symbol, easy peasy. Power and ground? Sorted with VDD and VSS pins. Decoupling capacitors, the unsung heroes of energy stability. USB and crystal circuitry, Precision meets connectivity. Think of decoupling caps as the Cyclone's morning coffee essential for smooth operations. Slide 7, Step 2, PCB Layout Placement Strategy, STM32 MCU front and center, like the Cyclone's cockpit. Decoupling caps nearby, they like to stay close. USB and switches, accessible but out of harm's way. Bad layout. That's how PCBs end up with a will not fly sticker. Slide 8, Step 3, Routing Precision in Action, prioritize critical signals, crystal and USB first. Keep power lines beefy for stability. Design Rule Check, DRC, the golden rule of clean PCBs. Routing is like playing Tetris with copper, it's all about fitting the pieces perfectly. Slide 9, Step 4, Manufacturing Prep. Generate these files, Bill of Materials, what you need to build your masterpiece. CPL, Component Placement List, where everything goes. Gerber files, your PCB's detailed map. Without Gerber files, your PCB's just a dreamer and not a good one. Slide 10, the Cyclone powered by STM32 outcome, a smarter, faster, more efficient Comet Cyclone. Why it matters: better recon, precise targeting, and operational reliability. Future vision: Cyclones flying through galaxies with STM32 power upgrades. A Cyclone with STM32 is like a space ninja with a PhD in awesome. Slide 11, Candor, let's power up. Ask about schematics, PCBs, or Cyclone trivia. Pro tip: no question is too small when designing big things. Unless you're asking if a Cyclone can make coffee. Sadly, we're not there yet. Page 4. Slide 1, Comet Cyclone meets STM32, the ultimate space mecha PCB. Subtitle, where high-tech meets high-speed. And a little bit of humor. Slide 2, Introduction. Welcome to the Intergalactic Design Party. 2 years of fantastic support. STM32 tutorial, 1 million views, because who doesn't love making PCBs? KiCad 6 tutorial now extended to include Comet Cyclone integration. Free Udemy course. No strings attached, promise. Sponsored by JLC PCB, because someone's got to make those spacefaring PCBs. Our mission? To make your PCB designs as legendary as a Comet Cyclone. Slide 3, Comet Cyclone breakdown. Key specs, origin, Robotech, Expeditionary Force Marines sourcebook. Affiliation, Robotech Marines, they have the coolest gear. Roles, recon, courier, sniper support. Basically, it's like the Swiss Army knife of mecha. Armaments, 6x60mm missile tubes, 2XGR-103 missile pods, EU-5 pulse beam rifle. Crew, just one pilot, because 2 pilots would be a bit much in that cockpit. This mecha doesn't need a team of engineers to be awesome. It just needs 1 pilot and some killer circuitry. Slide 4, why intermesh STM32 with the Cyclone. Advanced targeting system, with STM32, we'll make sure your missiles hit their mark every time. Power efficiency, no one wants a dead Cyclone in the middle of a mission. STM32 microcontrollers optimize power usage. High-speed data processing, for all the real-time analysis and decisions that come with spaceborne recon and sniping. Think of STM32 as the brain that keeps the Comet Cyclone from turning into a very expensive lawn ornament. Slide 5, Inductance and decoupling capacitors. Key points, place decoupling capacitors close to devices to manage quick switching transients. 100 NF capacitors for VDD and VAT pins. 10A micro F bulk capacitor near the IC. Think of decoupling capacitors as the Cyclone's shock absorber because even mecha need to stay grounded. Slide 6, Connections and grounding. Best practices, tie decoupling capacitors directly to pins and ground to ensure stability. Keep your schematic wiring neat. Precision is key to avoid your PCB resembling a spaghetti plate. Good wiring is like a clean cockpit. Keep it tidy, or the Cyclone's going down. Literally. Slide 7, Analog and digital supply filtering. Filter like a pro, add parallel capacitors, 10 NF and 1A micro F, for analog sections, for example, VDDA pin. Use a ferrite bead, 120A broken bar at 100 MHz, between analog and digital rails for clean signals. Just like a sniper needs a steady hand, your PCB needs steady, clean power. Let's not add any A-signal noise to your mission. Slide 8, Configuration pins. Pin configuration, NRST pin, connect a 100 NF capacitor for stability. Optional manual reset switcher because even the Cyclone might need a reboot. Boot 0 pin, add an SPDT switch with a 10K broken bar resisted to toggle between programming and running modes. NRST pin, press here for a Cyclone reboot, or just when things get too wild in space. Slide 9, Power supply, keeping the Cyclone alive. Powering up the Cyclone, ensure a 3.3 volts regulator for the STM32 microcontroller. Keep the microcontroller and auxiliary systems running smoothly for those laser-fueled, missile-happy missions. No power, no glory. No glory, no mecha battles. Let's keep the lights on. Slide 10. Additional circuitry for mecha mastery. More features. Connect a crystal oscillator for accurate timing because even mechas need to keep track of time. Plan for UART, SPI, and IR2C interfaces to maximize functionality and data exchange. Crystals aren't just for magic wands. They're the backbone of a properly timed battle strategy. Slide 11. The STM32 plus Comet Cyclone Ultimate Integration End Result, a mecha that can think faster, shoot straighter, and remain power efficient. Achieve high-speed data processing for better targeting and more efficient recon. Future vision. Imagine a fully integrated STM32-powered Comet Cyclones zooming across the galaxy with real-time mission updates. With STM32, your Comet Cyclone will be so sharp, it'll make other mechas jealous. Slide 12. Candor, mission control awaits. Ask away. We're here to talk schematics, PCBs, or who would win in a fight, a Cyclone or an RX-78 two-gun. Your questions could be the final piece in the mecha puzzle. No question too small a broken bar except maybe the one asking if your Cyclone can go to the moon. Spoiler, it already can. Page 5. Slide 1, Introduction, powering up the Comet Cyclone title, Intermission KiCad 6 STM32 with a Robotech Comet Cyclone, ready for takeoff. We're not just building a PCB, we're putting a Comet Cyclone into space. Get your booster seats on. Overview, integrating the futuristic design of the Comet Cyclone with modern PCB technology, combining STM32 microcontroller magic with mecha might. Slide 2, what is a Comet Cyclone? Origin, Robotech, Expeditionary Force Marines Sourcebook 1 Affiliation, Robotech Expeditionary Force Marines Design Features, Spaceborne Mecha Unit, complete with auxiliary boosters on the forearms rolls, recon courier sniper support armaments, 6 missile tubes, 2 missile pods, and a pulse beam rifle. It's like the Transformer of Space A but with more missiles. Slide 3, let's get technical. KiCad 6 plus STM32 equals magic key concept, designing a PCB for a spacebound mecha with real-world tools using KiCad 6 to design the circuit for controlling the Cyclone's armaments and flight systems. The STM32 microcontroller as small but mighty brain for our mechanical beast. Think of STM32 as the Cyclone's brain. Only smaller and more useful in combat. Slide 4, Crystal Circuitry, the heartbeat of the Cyclone crystal selection, 16 MHz crystal, 10 PF load capacitance, calculate, subtract stray capacitance from crystal load capacitance. This crystal is the key to sinking the Cyclone's missile pods with pinpoint accuracy. Just don't drop it. Pins 1 and 3, connect to STM32 oscillator pins. No feed resistor, because who needs extra stuff when you've got a mecha at your disposal. Slide 5, USB circuitry, the Cyclone's charging station USB micro connector, for easy compatibility, because even meshs need a charge. Boost power input, provides 5 volts nominal, no giant laser beams here, just good old power. Pull-up resistor, 1.5 Ki circumflex copyright on D+ for USB device detection. Even Comet Cyclone needs to plug in for its next mission. You wouldn't want it running out of juice in space. Slide 6, debug header, fixing bugs in the Cyclone's matrix serial wire debug, 1x4 mail header for all your debugging needs. Debugging pins, power, ground, serial debug, and clock signals, routing like a pro. Even the Cyclone needs some troubleshooting. Don't worry, no missiles are involved in the debug process. Slide 7, power supply, the engine behind the BSTAM's 1117 3.3 regulator, simple, stable 3.3 volts output. Power on indicator, a red LED tells you when your mecha is ready for action. The Cyclone won't leave you hanging. But you'll know when it's up and running. Slide 8, designator annotation, organizing for mecha warfare, sorting designators, sort by Y position you want your components in the right place for smooth combat. Manual sorting, logical organization for sanity. If you don't sort right, your PCB might get as messy as a battlefield. Slide 9, footprint assignment, putting components in their right place, symbols versus footprints. Schematic symbols are cool, but footprints are what make the PCB come to life. Footprint assignment, use KiCad's tool to assign footprints based on standard component sizes. Just like the Cyclone's armament, everything needs to be in the right place for maximum impact. Slide 10, PCB setup, preparing for liftoff. Board stack up, 2-layer board with top signal and bottom ground plane. Design rules, track width, via sizes and no mistakes allowed when building a mecha. Differential pairs, USB differential pair dimensions need to be spot on. A faulty track is like a rocket malfunction. Don't let your board explode mid-mission. Slide 11, final checks, before you launch. Verify schematic, check pinouts, component availability, and values. Differential pair dimensions, standard trace widths for USB data lines. Layer management, adjust grid settings for precision. Final check how no one wants to be caught mid-mission with an unsorted schematic. Slide 12, ready for liftoff. Conclusion, we've just built the backbone for the Comet Cyclone, combining space-bound technology with Earth-based tools. With this PCB design, the Comet Cyclone is ready to launch. Just don't forget to pack snacks for the pilot. Slide 13, thank you, mission complete. Candor, got questions about PCB design or spacefaring mecha? Ask away. Just don't expect me to explain how to survive a space battle. Page 6. Slide 1, welcome to the future of PCB design. Subtitle, where Robotech meets the STM-32 background image, a cool action shot of the Comet Cyclone in battle, if possible. Text, let's design like we're in the Robotech universe, but with a little more soldering iron and a lot less missile fire. Slide 2, Comet Cyclone Basics Origin, Robotech, Expeditionary Force Marines Sourcebook 1 Role, Spaceborne Mecha Unit A Recon, Courier, Sniper Support Armament, 6 60mm missile tubes, 2 GR-103 missile pods, EU-5 pulse beam rifle design, looks cool, moves fast, fights even faster. Much like your PCB when it's well laid out. Keynote, now, let's arm our PCB with power nano missiles though, unless you really want to get creative. Slide 3, let's dive into KiCad 6 with the Comet Cyclone Spirit. Key takeaway, just like the Cyclone, your PCB design must be agile, precise, and have the right amount of firepower. Design goals, power supply, smooth and reliable, like a well-tuned missile launch. Signal routing, no glitches, no interruptions, just pure precision, like a sniper shot. USB and debugging, we can't let the Cyclone get too far off course, so let's make sure we can always check our system's health. Slide 4, USB and debugging, the pulse beam rifle of your PCB USB connector layout, carefully place that USB micro connector, positioning it with the precision of an expert sniper aiming for a target. Serial wire debug, get the J3 connector aligned like you're aiming at the enemy. Rotate components like you're getting into optimal firing position. Fun fact, if only debugging a mecha was as easy as just flipping a switch. But we'll settle for this 1.5Ki circumflex copyright resistor. Slide 5, power supply, how to keep your Cyclone powered up. Linear regulator, AMS 1117 3.3, keeping the voltage steady. Power is key. Just like the Comet Cyclone's thrusters, it needs to stay on course. Power indicator, let's keep an eye on that red LED. If it's on, you're ready for action. If it's off, we're on the bench for some recalibration. Visuals, add a diagram showing power routing with a side comment like you wouldn't send a mecha into battle with low power, so don't let your PCB go into battle underpowered. Slide 6, routing your PCB at the real-time navigation system. USB differential pair routing, no room for errors here. These lines need to be as clean as a high-speed chase through an asteroid field. Signal routing, just like guiding the Comet Cyclone through enemy territory, you want to route signals with precision. Tip, good signal routing is like good tactics. Never underestimate the value of a clear path. Slide 7, component placement, setting up your mecha for success. Fine-tuning layout, it's all about the details. Even your components need to be in perfect alignment. Just like the Comet Cyclone's boosters on the forearms. Fun fact, component placement is like choosing the right weapons for a mission. Too close, and things get messy. Too far apart, and things get slow. Visuals, a graphical representation of well-placed components. Slide 8, creating a filled zone, ground control to major power. Why ground planes matter, imagine the Comet Cyclone's stealth mode. A good ground plane keeps your signals stealthy, reducing noise and interference. Filled zone setup, set up your copper zone for ground to minimize issues. Your PCB's ground plane is its shield. Let's make it solid. Cool tip, a good ground plane is like the Cyclone's armor, it's what keeps you safe when the action gets heated. Slide 9, routing signals are the art of the perfect shot. Signal routing best practices, start with decoupling capacitors. You want to ensure that critical components get the right juice without interruption. Think of it as loading your sniper rifle with a perfect round. USB differential pair routing, perfectly aligned anode twisting wires here. Power and ground routing, use wide traces like the Cyclone's wide-reaching missile pods. You want power flowing like it's mission critical. Because it is. Slide 10, verification, the final mission brief. 3D viewer check, it's like getting in the cockpit of your Comet Cyclone. Check all systems before launch. Final tune-up, adjust components and traces. Make sure everything is in its place and running smoothly. Humor twist, no one wants their mecha to have a bad day before a mission. So double-check your layout, and avoid any catastrophic crashes. Slide 11, bonus round. 8 common pitfalls to avoid lack of proper clearance, just like leaving a hangar door closed when your Cyclone needs to take off. Overcrowded routing, too many lines? Looks like you're heading into a traffic jam. Keep things clean. Forgotten wires. A PCB without wires is like a mecha without thrusters. Don't forget them. Slide 12. Conclusion A. Your PCB is ready for battle. Text. Just like the Comet Cyclone, your PCB should be powerful, precise, and built to last. A little patience, a lot of strategy, and a dash of creativity will make sure your design wins every time. Closing joke. Now go out there and make that STM32 powered mecha design shinier. After all, even in the world of Robotech, it's all about getting the job done without blowing out the base too much. Slide 13. Q&A time. Let's chat. Text. Got any questions about blending mecha warfare with PCB design? Let's talk shop. Visual. A picture of the Comet Cyclone raising a thumb up. Because every good engineer deserves a moment of victory.